I'll be recording today's presentation, so it'll be downloadable within about 24 hours after it's over. All right, let's go ahead and get started. I'll start by introducing myself. My name is Brian Kettleson. I'm the co-founder of Gopher Academy, along with Eric St. Martin. We also run GopherCon, which is the yearly Go conference in Denver every year. You can see that at gophercon.com. We would love it if you came and joined us in Denver. If you can't make it for whatever reason, we'll probably be live streaming on Twitch again this year because that was so much fun last year. It's well worth doing again. So this class today will be recorded, and if you attended the class, you'll be able to go back into the class page tomorrow probably. It usually takes them about 24 hours, and you can download the recording or watch it again on air if you miss any of it or if your attention gets pulled away on a PagerDuty call for whatever reason. So I'd like to start by introducing the concept of this class first. We decided a few weeks ago that there just wasn't a lot of practical free Go training available, and decided to do our best to try to do at least one of these a month, if not more often, for an hour long, to try to deep dive into a specific topic that people have requested. And one of the things that we hear most often is people who don't have a lot of Git experience don't understand how to do pull requests. And especially on a Go project, that could be complicated. So today's class is on how to do a pull request against a Go project. And that's what we're going to be diving into. If you have questions along the way, use the chat feature of BigMarker, and I'll stop every once in a while and take a look at those questions and answer them as we go. Or you can raise your hand, either one of those works, and we'll go from there. Feel free to be as interactive as you want to. There's no reason you have to just sit and listen. It's all about getting your questions answered and interactivity. So with that said, let's get started. All right, so today we're going to talk about 4 specific things in regards to submitting your first pull request on an open source project. We're going to start talking about Git etiquette, how to handle yourself when you're working in an open source project, what kind of things to do, what kind of things to avoid. We'll talk about the mechanics of a pull request, the actual the Git process, the workflow, and we'll talk about specifics related to doing a pull request on a Go project, because Go and the Go path make things a little bit different for you. And then I'll end up with a few links to some resources for further learning. So let's start off by giving ourselves a big hand. The idea that you've decided you want to start contributing to open source is an awesome thing. It's a great decision. There are a lot of benefits to open source, and you'll enjoy a lot of them. My benefits and my favorite ones so far have been giving back to the projects that I use, making a lot of friends. I've learned a lot of new things, and playing in open source has given me a lot of new ideas, taking pieces from project A and pieces from project B and mashing them together into a new Franken project that does crazy things. I've really enjoyed that. I think my life is significantly richer since I've been an active open source contributor, and I've made some really nice long-lasting relationships. So I hope that you'll find those benefits too. So let's start with Git etiquette. Before you dive into any open source project and start submitting pull requests, it's very important to consider the social aspect of contributing to open source. We're going to talk about a few of the scenarios briefly and the generally accepted ways to communicate in each of these scenarios. The most important thing that you need to remember is that there's a human being on the other side of GitHub. There's always a human being at the other end of this. So just treat everybody with courtesy and respect and patience, and things will go generally well for you. So the first scenario is one where you've found a bug in a project that you're working on or working with, and you want to fix it. That's awesome. That's the best thing in the world you can do. So you'll start by opening an issue in GitHub. Go to their project and say, I found an issue. It seems to be broken. Confirm that it's an issue with them, and let them know that you're willing to submit a PR with a fix. Step 2 is to wait for a response to your issue. The maintainers of the project will confirm that the issue exists, and more than likely, the fact that you're willing to submit a PR will make them jump up and down and scream with delight. So chances are pretty good that you'll get a pretty quick response to that. Then read their response in step 3. And if they tell you go for it, then make the fix. The second scenario might be where you want to make an enhancement to a project. Every open source maintainer enjoys when somebody else writes code and submits it to their project. So adding features to an existing project is an awesome thing because it's code that an open source maintainer doesn't have to write, and their features that maybe they wanted to add but didn't have time. So once again, you're awesome. Thanks for contributing to that open source project. Step one, you want to open up an issue again. Suggest the enhancement that you want to make and that you're willing to submit a PR to do it. Again, you need to wait for a response to your issue. Often the maintainers of the project may have already thought of that issue or may have already thought of that enhancement, and they have a specific way that they want to do it, or they're holding off on that enhancement because a re-architecture that they've planned might make it easier to do in the future. So wait for their response, and if it's green-lighted, you can make the fix. But pay close attention to any direction the maintainers give you or any guidance that they give you, and follow their guidance, because they have an idea probably mapped either in their roadmap on the GitHub repository or in a roadmap that's in their mind about how they want the project to evolve. So if they give you direction or guidance, following that will make it much more likely that your pull request will get merged. For any pull request that you do, you need to check the documentation in the README in the root of the repository and look for a contributing.md file. Those files often have explicit instructions on how you should proceed with a pull request. Sometimes they're extremely explicit. You need to use a specific branch in your pull request. You need to name your pull request a specific way. You need to use specific wording in your commits for Git. So pay close attention to those, because the things that they request of you are things that make their workflow easier as a project maintainer. Therefore, paying attention to them will give you a better chance to get your pull request merged. If you choose to ignore them, it's very likely that your pull request will be deleted, or at worst or best case scenarios, they'll tell you to resubmit it with following those guidelines. So this is truly the most important step of all. Pay attention when the project tells you how they want you to interact with them, because that's the best route for you to have success. So let's talk about the mechanics of a pull request. Now that you've done the important part of communication in your open source adventure, it's time to start making changes to source code. So let's look at how a pull request works. Generally, you're going to start by creating a fork of a repository that you make your changes in. It's the easiest and cleanest way to contribute changes back to a project. If you're a member of the project team, you may have permissions to create a branch inside of that project instead. This is a less likely scenario when you're working in open source. A branch works in the same Git repository. A fork uses a different repository. The fork button at the top of the GitHub repository will pop up a screen that asks you whether you want to fork it, and you just hit yes. So after you've hit that fork button on GitHub, you end up with a copy of the project on your GitHub account. Let's go look at a project. So here is SPF 13 Viper, which is a configuration management program in Go, a library in Go that lets you do configuration management. If you wanted to fork Viper, you would hit the fork button, and then you would choose which one of your Git organizations that you want to fork it to. In my case, I might want to fork it to B. Kettleson, which I don't even see in here. Where am I? Oh, I've already forked it as B. Kettleson, that's why. Here we go. Here's my fork, B. Kettleson Viper. So you can see if I hadn't already had one, it would show a pretty graphic here that said, it looked like a photocopier that said it was forking this repository. And then it would drop me on this page, which is my fork of the original repository. So now we need to make a local copy of that fork in order to make changes to it. So after we've made our fork, we'll hit the green clone or download button inside your own fork of the repository. So hit the clone or download button. If you have SSH keys installed on GitHub, you'll want to choose the clone with SSH button and then select the URL and hit copy. And then paste that into your terminal window and clone that. So we hit the clone button, we choose the SSH button and get the URL of the repository. And then in your terminal window, navigate to the directory where you want to keep your projects and type git clone and then paste the URL there. So once you've got a local copy, change into that directory and type git checkout -b, my branch name. So we're going to create a branch that lets you keep the changes that you're making self-contained. This will allow you to create a package of changes that you can submit upstream later to the original project. So it's very common for people to use descriptive names for your branches, and it's also kind of polite in that same Git etiquette vein. So a good name would be descriptive and short, something that tells exactly what you plan to do with your branch. Update -homepage, fix model errors, add download feature. All of those are small and short branch names that help the people that are looking at your branch understand why the branch exists and what you intend to do with it. So step 3, after you've got a local copy of your code, you can start getting to work. You'll make your changes, and it's very important to follow the style of the code around you as a guide. If you're adding a new function to a package in Go, use the same naming conventions that they have. If they have variable names that are short, use short variable names too. If they have other patterns in their code or file names, use those same conventions. It will make your code blend in with the code that's already there. If you have any questions about that at all, ask a question in the issue that you raised in the first step. Communication now will help prevent frustration in the future, because at some point somebody's going to look at the code you wrote and decide whether it meets the standards to be included in that project. So making your code blend in with the code that's already there is a great first step to do that. Tests. Everybody loves tests. Tests help us sleep at night. They're important for everybody. So if the project that you forked has a test suite, which it should, or maybe the pull request you're sending is their first test suite, that'd be kind of nice too. You'll want to run the test suite after you've made your changes to ensure that you haven't broken anything. You may need to update existing tests that broke because of new code you added or because they relied on things that were broken before. So you'll want to update existing tests and then add a test to cover the new code you've written or the bug you've fixed. There is truly nothing better in the world than a very clear and specific test that highlights a bug fix when you send in a PR. Some projects specifically require that. The Go project is a good example. If you're going to fix a bug in the Go project, they require a test that targets that specific case. So having a test that targets the exact bug that you're fixing is a great thing, and it's a good way to ensure that your test or your code fix works, and it's a very friendly way to get a pull request merged. Step 4, you need to check in your code. So you'll want to look to see the files that you've modified by typing git status on the command line. First PR module.markdown file here is the code that powers this slide. So when I was building it earlier, I typed git status and it showed me that I was on master branch, and I have not yet added the changes that I've made locally to the module.markdown file. So I know which file I've changed locally. Now I need to add it to the git staging area. So step 1 is to add your changes to a commit. You'll want to use a well-written commit message that explains what you did and why you did it, and specifically what it adds or fixes. Mention the GitHub issue that you opened in the commit message. So step 1 here is to add the file to the git staging log, and then step 2 is to commit it. And we type git commit -m with a message. This change adds a new button to the home page, allowing users to download the pictures as a zip file. And the last part fixes number 12. That number 12 should correspond to the issue that you opened on the GitHub repository of the original project. So it's a clear and concise message that explains exactly what you did, why you did it, and mentions the issue in GitHub that you raised earlier. When they accept and merge this pull request, it will automatically close that issue in GitHub and tie the commit to the closing of that message. So they have a nice, clean log, and status of events as that project or the pull request gets merged. So we git add and then git commit. The next thing we want to do is push our changes to our fork. So I type git push origin master, or if we created a better branch name earlier, like add homepage button, you would type git push origin add homepage button, and that pushes your local branch on your computer to GitHub. And it tells you when it's done, branch master set to track remote branch master from origin. Origin is the name of the remote in Git, and we'll talk a little bit about that later. But that tells you that your pushes or your changes have been sent up to the server. So the fun part now comes by opening up your pull request. You're going to want to navigate to your fork on GitHub and click on the pull requests tab. So let's see what that looks like in my fork here. I've got my fork of Viper. If I click pull request, if I had any changes here, it would suggest you just made a commit. Do you want to make a pull request? Since I don't have any changes, I'll just click on the new pull request button, and it's going to ask me what changes I want to suggest. I have a branch here, but it's already been merged, so it doesn't make any sense to try to do it live on GitHub. So let's take a look at a screenshot of what that would look like. This is actually a little bit old screenshot. Some UI changes have come to GitHub since the screenshot was taken, but it's still roughly the same. On the left side of the screen, you see the base repository. That's the repository that you forked from. So in our case, SPF13/Viper. And on the right side, you see your repository, your fork of that, and then your branch. So you want to create a pull request that compares your repository and the branch that you've been working in against the base repository and probably master branch, unless their contributing guidelines tell you to send your pull request to a different branch. The next step is really important. You need to give your pull request a clear title and a well-worded description. So the clear title should state, again, what the pull request intends to do, and the description should say how you did that and what you did to change it. So an example might be a title of added a download link to the home page, and the description is this pull request adds a new download feature to the home page so that users can download all of the images that they've updated. When you're done creating your title and adding a nice description, you hit the green Send Pull Request button, and that pull request is submitted to the project maintainers. This is the part that is less fun. This is where you have to wait for the open source maintainers of that other project to look at your pull request. Remember here that they are people with lives just like you. They've got jobs and families. Almost everybody that works in open source is donating their time to these projects. So be patient with them. It might take a day. It might take a couple days. Just never get rude with them, because that might hinder your ability to get your pull request merged. When they look at your changes, they might suggest that you do things differently. If you do, all you need to do is make the changes in your local fork and push them back to your local or to your GitHub repository again. It will automatically update the PR. Someone has a question. Oh, Carolyn. Hi, Carolyn. How you doing? Do you have any thoughts on pushing with -- force versus adding new commits when updating a PR with their feedback? I always add new commits, and if they want later, we can squash or rebase. But I like new commits because they give a very clear path in my mind for the thought process that happened during the development cycle. If they want a single commit in their Git log, then they can merge with a squash merge. That's a new feature that GitHub just added. So generally the maintainers of the project will tell you if they want that. I personally prefer lots of commits versus one big commit. Great question. So the maintainer might suggest changes. When they do, all you need to do is make your changes locally and push them back up to your fork on GitHub. it will automatically update the PR, and you may have to go through this cycle 2 or 3 or 5 or 20 times until you get the pull request looking exactly the way the maintainers of the project want it to look. My first commit to the Go project frustrated me so badly because I was so inexperienced with Go that I abandoned it. And it took me another couple months before I had the courage to try again. And that time I went through, I want to say 5 or 6 changes to my code before the Go team would accept my contribution to Go. Obviously, a programming language is a finicky and fickle thing. Most of the projects that you're going to work on might not be that complicated, but you will often get feedback where they suggest renaming variables or moving functions around, small feedback like that. When you make those changes, it will automatically update the PR, and after a cycle or 2 of that, they'll either say this isn't going to work and they'll abandon the PR, or they'll merge your pull request. That's the happiest day. So once you get your pull request merged, you're a contributor to the project, and you've given back to open source, which is an awesome thing. Unfortunately, in Go, things are a little bit more complicated because of our Go path. So when you have a Go project and you fork it over into your own GitHub repository, the source directory doesn't match the namespace of the project anymore. So our example before where we had SPF13 Viper, my fork of that is at github.com/bkettleson/Viper. But the code inside my source repository here has SPF13 as its namespace, its import path in Go. So if I were to type go get or go install with this package, it will install it using the SPF13 Viper namespace, and my code will be completely ignored. So in order to get around that problem, we have to play some tricks with Git and file path problems. So the important thing to remember is that the namespace, the import path of your library, is directly related to the location on disk of your library. So if your Go path is your home directory, then under source github.com/SPF13 Viper is where the Go tools are going to look for the Viper package. If yours lives in your home directory, it will be completely ignored. So you really have 2 choices, and one of them is ugly. Your first choice is to change all the import statements in your fork to match your Go path. So I could go back to Viper here, and in every code file here, which is actually just 2 code files, it isn't that big of a deal, change SPF13 to bkettleson. And then I can make my tests and write my code and then change it back before I submit my pull request. Or we can put our fork of our project in the original project's import path. Don't ever do the first one. It's just a recipe for disaster. I don't know how many pull requests I've seen to open source projects that have the import path changed in the import statements from the fork. And it's ugly, and people forget to change them. And if the open source project doesn't have good tests and somebody doesn't catch it, we'll end up breaking everything because the packages are now split between your GitHub repository and theirs. So really the only true answer here is to put your fork in the original project's import path. So let's talk about the mechanics of that. So what does that mean when you say put your fork in the original project's import path? It means that you check out your GitHub repository in the upstream project's import path. In this example, I would check out bkettleson Viper at github.com/SPF13 Viper. Now the project lives where it's expected to be, and everything is right with the world, almost. You can make your changes here, and you can push them upstream. The only real problem is that you lose the original project. So the last thing that we have to do is figure out how to track that original project. We don't want our fork of SPF13 Viper to be used when we build apps that depend on it. We want the upstream project to be used. So again, we have two choices. We can add a git remote to the upstream project, or we can delete our fork when we're done with the fix and replace it with the original upstream project. So in that case, we would clone it under SPF 13 Viper, make our changes, make our pull request, get it merged back into the upstream project, and then we would delete the local copy of SPF 13 and then just go git again. The choice that you make here really depends on how often you think you're going to be working in that project. If it's just a single change and you don't expect to make any further changes, I would just delete the fork and do a go get on the original project after your change set is merged. If you're going to be making a lot of changes to the project in the future, you might need to use some more git magic. So that's what we're going to discuss next. A git remote is a fancy way of saying another place to push or pull changes in Git. Git is a distributed version control system, and it's decentralized in nature, unless everybody is using GitHub, and then in which case it's actually centralized in its decentralization. But generally, Git doesn't care where you're pushing to or pulling from, and the concept of origin and other remote names are nebulous. Origin is nothing other than a remote name to Git. There's no magic behind the word origin. So if you want to see what the remotes are configured for a Git repository, just type git remote-v, and it will show you the remotes that you have configured. On the slide that we've got on the screen here, I've got two remotes. A remote called origin for fetching, which is when we pulled data down from Git, and a remote called origin for pushing. So you could actually split your remotes and use different locations for pushing versus pulling. So this example shows that the origin of my repository is a remote in Git that points to my fork of SPF 13 Viper. But I said earlier that you could have a lot of remotes because Git is a distributed protocol. So let's add another remote to this project, and we'll add a remote called upstream that points to the original project. To add a new remote representing the original project, issue the git remote add command. Here we type git remote add. We'll give it a name called upstream. You can use any name you want, but upstream is a convention that most people will use. And then give it the path to the upstream project, SPF 13 Viper. Now we have a git remote called upstream that points to the original project. So in my fork of SPF 13 Viper, which lives in the correct import path under github.com/SPF13/Viper, I've got my GitHub account linked as origin, and I've got Steve's listed as upstream. That allows me to make changes to my fork of the project, but I can still track the changes from the upstream branch. In order to do that, when you're working on your change, you can create a new branch and make your change and send the pull request following the workflow that we've already shown here. When you're done with the change, all you need to do is move back to the upstream master branch. So the upstream is the git remote and the master is the name of the branch, and that represents the original project. So we type git fetch upstream space master, and that pulls down all of the changes from the upstream remote on the master branch, and then check out upstream/master. I don't know why there's a difference between these two commands, but there is. So git checkout upstream master, and that puts the local repository in the position same condition that the original project is in. So this puts our project pointing to Steve Francia's version of SPF 13 Viper. That means that later, if I want to make another change, I can just check out origin, which is my copy, and make a new branch, make a change, push it up to GitHub, create a pull request, and when that pull request is done, I can fetch upstream master and check out upstream master again, and I'm using the original project's code. So this is a little bit complicated and confusing, which is why I don't recommend that you do it unless that you intend to make a lot of changes to a specific repository. Most of the time, I will make a local copy and delete them because this is a little more work than I like to do. If I forget later that I have a fork of this checked out in place in SPF 13 folder, I might do a git pull thinking that I'm getting the latest code, but I'm actually pulling from my repository, not from the SPF 13 repository. And that's when I have to stop and remember, oh, wait, I've got an upstream origin here. So this isn't something I would do long term unless you're always going to be working in your fork. So git checkout upstream master makes the upstream master branch the current branch in your workspace. And that allows you to keep working in your local copy, but use SPF 13 Viper from Steve's copy when you're not working in that local branch. So that's the magic behind submitting a pull request to your first GitHub account. Let's see. Oh, we've got a question already. What's the difference between a rebase and a merge? A rebase is not really related directly to a merge. A rebase takes the target branch and replays all of your commits over the top of it. So that you might want to do a rebase. In fact, you generally need to do a rebase if there have been changes active in the origin repository and the original repository while you've been working on your code. So doing a git rebase will take all of the changes that you've made and it will replay them on top of the remote repository's master branch. And that allows you to take those changes but accept anything else that's happened during the time you've been working on your project. So a rebase just replays all of your code on top of a specific git commit, and a merge adds your code to the repository. So they're two separate things. Rebase is important when there have been changes while you've been working on your project. I hope that answers your question. You don't always have to rebase, but if it's a very active project, it can be useful. Perfect. So I put 3 links up on the screen here, and I'm going to copy and paste them into our little chat thing because I found these articles very helpful when I was putting this together, and they go into a little bit more detail than I have. Are those 3 links, or are they 2? Oh, they're all bunched together. Hang on. I'll paste them separately. There we go. Stephen asked, what if you're using a package manager like Glide? That really doesn't change anything. You'll still want to have your checkout in their import path and follow the Glide process or whatever dependency management process that they have. If you're adding new dependencies to the project, then you need to know whether or not they check in the vendor directory or whether they just check in the Glide lock files and follow that pattern. Some projects like to have the vendor directory checked in. Some projects hate to have the vendor directory checked in. That's a project maintainer's choice. But the package manager shouldn't make any difference to your Git workflow at all. You're welcome. All right, any other questions? Would it work if I create a symbolic link with my original repository name pointing to my repository? Yes, it would. But again, it's one of those things that you might forget that you've done and get you in trouble later. So symbolic links absolutely work in the Go tool chain, but it's another way to invite a forgetful disaster in the future. So I think I started using symlinks very early on in Go and just decided that they weren't worth the trouble. All right, if there's no further questions, then I really appreciate you coming today, and I'm excited to see you guys start committing to open source Go projects. If you do, send me a mention on Twitter, and it will make my day. So my Twitter account is bkettleson. Send me a link to your first PR somewhere, and it will make me really happy. Thanks for attending today, and I think I set this up to do a a survey at the end of the class. So if you like the class, if there's anything you want to change, let me know. If you didn't like the class, let me know too. We intend to do as many of these free classes as we can, and we'll start adding some longer paid classes too soon. So love everybody for showing up. Thank you so much. And the video for this will be available tomorrow. Oh, slides. Oh, good call. Hang on. Let me pull up the slides. I created an export of the slides here. So let me dump those into the directory. Where is my source directory? Just a moment here. Good call. Thanks for reminding me. GitHub. Where is it at? My Go path is so huge, it's 13 gigabytes on my disk. So it takes me a while to find things. Be patient. Gopher Academy, where am I here? Gopher Academy, there we go. All right, share a file. All right, it's converting the file, and then it should drop it into the whiteboard. Give that just a second. And hopefully that will allow you to still download it. Excellent. All right, let me see if there's any buttons I need to click to make that downloadable. Okay, is that available for you to download? Yes, Anderson asked if we'll get a link to view the presentation. Yes, absolutely. You will get a link by email. So can somebody confirm that you can actually download the PDF before we end this? No, you can't download the PDF. Darn, is there a handouts thing? Where are handouts? Hang on, I'm looking for the handouts link. There's got to be one of those, right? Oh, handouts. Well, that would help, wouldn't it? There we go. There we go. The PDF for this is in the little handouts tab. Good call. Was that Carolyn? Of course it was Carolyn. Thank you, Carolyn. I believe that the links in the chat will be available, but they're also in the PDF. So if you go into the handouts tab of your Big Marker, you should be able to pull down that PDF, and all of those links are in there. All right, so thank you everybody for coming. I appreciate it, and hope we'll see you again soon on another Gopher Academy free class. Thanks a lot. Bye.